Hey everyone, and welcome to BK'sTechStack. Today, we're tackling a fundamental topic in software development, object-oriented programming, or OOP, in Python. This session is designed as a beginner's guide, covering all the core concepts, essential syntax, and practical use cases. By the end, you'll have a solid grasp of how OOP empowers you to write cleaner, more efficient, and scalable code.
At its core, OOP is a powerful paradigm that organizes software design around data rather than functions and logic. It's about creating objects that encapsulate both data and behavior. The foundation of OOP rests on four key pillars: inheritance, encapsulation, polymorphism, and abstraction. These principles collectively allow us to write highly structured, modular, and maintainable code, which is crucial for complex applications.
Now, let's dive into the fundamental concepts of classes and objects. Think of a class as a blueprint. It outlines the structure and behavior. An object, on the other hand, is a tangible instance built from that blueprint. In Python, the __init__method is your constructor, setting up your object's initial state, and self is how an object refers to its own properties. This syntax forms the very foundation of how we define and create objects.
Next, we explore inheritance, a powerful OOP concept that lets us build new classes based on existing ones. This is all about code reuse and creating a hierarchy. A child class can inherit traits and behaviors from its parent, extending or modifying them as needed. This allows for a more organized and less redundant codebase, clearly establishing is-a relationships, like a cat is an animal, but with its own unique speak method.
Encapsulation is all about bundling data with the methods that operate on that data, effectively hiding internal details and protecting data integrity. While Python doesn't enforce strict private variables like some languages, it provides conventions like the single and double underscores. The double underscore in particular triggers name mangling, making direct external access difficult. This ensures that an object's internal state is only modified through its defined methods, adding a crucial layer of control and preventing misuse. Polymorphism, meaning many forms, is a cornerstone of flexible and dynamic programming. It allows objects of different types to be treated uniformly through a common interface. We see this in method overriding, where child classes adapt a parent's method to their specific needs. Python also embraces duck typing, where an object's behavior, not its explicit type, determines its compatibility. If it has the necessary methods, it's good to go, making our code incredibly adaptable.
Finally, we have abstraction, which is all about simplifying complex systems by focusing on what's essential and hiding unnecessary details. It defines a clear contract for how objects should behave without revealing their internal workings. In Python, abstract base classes, or ABCs, are crucial for enforcing this contract, requiring subclasses to implement specific methods. This principle is invaluable for creating robust and extensible architectures, like designing plugins that all conform to a universal interface.
All right, we've journeyed through the core of object-oriented programming in Python, from classes and objects to the four pillars: inheritance, encapsulation, polymorphism, and abstraction. Understanding these concepts is fundamental to writing clean, maintainable, and scalable Python code. My biggest advice is to start implementing these ideas in your own projects. Don't forget to like, share, and subscribe for more tech insights, and leave any questions in the comments. I love hearing from you.